Hello, students. Welcome back to the video lecture series of structural analysis. So, in the last two, three classes, actually have discussed about how to analyze a continuous beam by three-moment theorem. So, we extend that topic again today with a different scenario. So, let us first apply this three-moment theorem in the case where the support of the continuous beam is settled down by some mm centimeter, right? So if it is given the support is sinking by any measurement, so how can we apply the three moment theorem? How can we modify the three moment equation that we will see today? Okay. So let us just refresh the knowledge about the three moment theorem. Why we are using three moment theorem? We are using to determine the support moments. Then we can simplify the analysis of the continuous field. Then we can avoid solving many simultaneous equations. So this is the basic equation we have actually used in solving the continuous beams by using three moment equation. So this is MA into L1 plus 2MB L1 plus L2 plus NC into L2 is equal to minus 6 into A1 X1 bar by N1 plus A2 X2 bar by N2, where this MA, MB, and MC are nothing but your support moments. This L1 and L2 are span length. A1 and A2 are area of the free bending moment diagram of the span. X1 bar and X2 bar is nothing but your central distance from the each support. So yeah, let us just refresh what is this area, which area we are calculating, and what is the central distance. So this is a free body diagram of each span of any continuous beam. This is, let's say, span A and B, and the load is 30 at distance A from support A. So in that case, you just find out the support reactions. The support reactions are PB by L1. This support at B is PA by L1. So if you find out the movement under the pointer, let's say PB into L1, PB by L1 into the perpendicular distance. This PAB by L1. So what is the area one? Area one is area of this triangle. So half into base into height. So we are getting PAB by L2. So in that case, your centroid will lie at this particular point, and the centroid to left support distance is XL. So how can we calculate the centroid distance? That is A plus L1 by 3, and centroid to right support is B plus L1 by 3. So in the other span, if it is simply supported, let's say span B and C, and it is the W kilonewton per meter. So in that case, the maximum bending moment will get W square by 8. And the area 2 is 2/3 of base into height. So centroid will lie upon the center, that is centroid to left support, that is XL, and centroid to right support, that is XR. And the distance from centroid to left support is L2 by 2, which is similar to XR. Coming to the example of three moment application of three moment theorem for the simply supported beam. But what is the difference here? Here it is three spans and sinking of the support. Okay. So here is the question is given the three span beam, that is span A, span AB, BC, and CD. The length of AB is 6 meter, length of BC is 6 meter, and CD is 3 meter. Point load is acting upon the span AB, which is 2 meter distance from B. That point load is 30 kilonewton. Another point load will be 60 kilonewton acting at the center of span BC, and another point load of 40 kilonewton will be acting at center of span BD. Okay. What else is given in the question? The support C sinks by 5 mm. That means the support C is settled down 5 mm below B or D. Okay. So the value of E is given 15 kilonewton per mm square and I is given 5 into 10 to the 9 mm. The task is we have to use free moment theorem to determine the bending moment and support A, B, C, and D. So this diagram is nothing just to showcase a scenario. Let's say this continuous beam A, B, C, D is one of the continuous beam in this warehouse, and the other loading conditions in the warehouse. Okay? Yeah. Let us first, the first step is to draw the body diagram. Draw the free body diagram. So first, draw the free body diagram of span AB. So span AB, which is 4 meter from L and sorry, A and 2 meter from B. Okay. So the point load is 30 kilonewton. In that case, what will be the bending moment? The bending moment is the same way what we have discussed earlier. So this support reaction will be PB by L. So PB by L into A. So P is here 30 kilonewton. A is your 4 meter. So B is your 2 meter divided by 6. Okay. This train show total is 40 kilonewton meter. This the total height is 40 kilonewton. So what is the CG distance? XL is A plus L by 3, that is 3.33. And area 1, how can we calculate? That is half of base into height, that is 120. Similar fashion, we can calculate for span BC, where point load is at the center. So the bending moment, maximum bending moment will be WL by 4. W is here 60, L is 6 divided by 4. We are getting 90 kilonewton meter. How can we calculate area 2? Area 2 is up into base into height, 370. XL and XR are the point load is at the center. So XL is 3 meter from left support, XR is 3 meter from right support. So it is XL and XR is 3 meter. Span CD. If you draw the free word diagram of span CD, so this is C and D, and the point load is at center, and the total span is 3 meter. In the same formula we apply WL by 4. Here W is 40 into N is 3 divided by 4. So we are getting 30 kilonewton meter. And area 3 is half into base into height, okay, 45. XL and XR, that is nothing but half of the span, that is 1.5 meter XL and 1.5 meter XR. Now we apply the three moment equation to solve this continuously. So before that, what is the condition is given in the question? That is support C is 5 meter below the mid support B. So support C is 5 meter below the mid support. So we can consider HC is minus 5 mm. We have converted that mm into meter. So 0.005 meter. And this value, the value is given in the question 15 into 10 to the 6 kilonewton per meter square. So when we apply the three moment equation, as we have discussed it before, three moment equation can be written for consecutively three support conditions or three consecutive supports. So support A, support B, and support C. We having two spans, and so span AB and span BC. So we will write the three moment equation. So let us write the three moment equation. The three moment equation will be moment at A into L1 by I1 plus 2MB into L1 by I1 plus L2 by I2 plus MC L2 by I2 is equal to minus 6A1 X1 bar by L1 I1 plus 6A2 X2 bar by L2 I2 plus here the extra thing we have added in the previous formula, that is 6E HA plus L1 plus 6E HC plus L2. What is this? So This is nothing but HA is nothing but height in the settlement at support A, height of the settlement at support C. So as we are writing for the span AB and BC, so let us decide which segment will be zero. So this is the end support. Again, I'm drawing it here. Span A, B, span A, B, C. So here, span A is the end support. End simply supported. So whatever movement at A will be zero in the pattern. Right? Is there any movement at B? Yes. There is some values we have to find out. Is there any movement at C? Yes. There is some value which we have to find out because it is the intermediate support. Because it is the intermediate support. So what else we can put zero in the equation? So one thing is height at A, the settlement at A is also 0 because there is no settlement at all. So instead it is given the settlement at C is 5 mm. So there is a settlement at C, but there is no settlement at A. So this two segment will be 0. One is MA is 0. So this MA into L1, sorry, MA into L1 by I1 will be 0. And HA will be 0. So this 6EA HA by L1 will be 0. So now rewrite the equation again. If we rewrite the equation, so it will be 2AB multiplied by 6 by 2R plus 6 by 2R. You see, I1 and I2. I1 and I2 are both are 2R. So 2MB 6 by 2Y plus 6 by 2Y plus MC 6 by 2R, that is I2, is equal to minus 6 into 120 is nothing but your A1 into 3.33, that is your X1 bar divided by L1 I1 plus 6 into A2, that is 270 we have calculated, into 3, that is X2 bar divided by L2 I2 plus 6 into E is your 15 into 10 to the power 6 kilonewton per meter square into H1 is given in the question minus 5 mm. So that is nothing but 0.005 meter. So minus sign is given because the settlement is downward. So minus 0.005 meter is the settlement divided by N1. Sorry, L2. L2 is also 6 meter. So again, rewrite the equation. So the equation is 2MB into 12 by 2I plus MC 6 by 2I minus, we have solved this part, that is 199.8 divided by I plus 4 plus 5 divided by I minus 6 into 15 divided by 6 into 0.005 divided by 6. So this is the final equation. This is the final equation. So in this equation, if you multiply both sides by I, that means we are trying to cancel out this I values. So 12MB plus 3MC is equal to minus 199.8 minus 405 minus 6 into 15 into 10 to the 6 into 0.005 into 5 into 10 to the minus 3, because this is the value of I. So here if you multiply with I, so I will be cancelled out. Here you multiply with I will be cancelled out. Here also you multiply with I, so I will be cancelled out. So you have to again multiply here I values. So I value is 5 into 10 to the minus 3 divided by L2. So what is the final equation? The final equation is 12MB plus 3MC is equal to minus 979.8. That is your equation 1. Now, coming to the second equation. So, what is the second condition? Second condition is you have to consider the span B, C, and D. So, this is span B, C, and D. The loading condition is, sorry, this is slightly higher, so 6 meters, and that is 3 meters. So the loading condition is 60 kilometer at the center. You can see from this figure. And here the loading condition is 40 kilometer at the center. So we'll just apply the three moment theorem for the span BC and CD and we'll rewrite the equation here. So carefully look into the equation. What is the sequence of the components you can see. So the sequence is MB into L2 by I2 plus here using the B support, so obviously MB will come. So MB into L2 by I2 plus 2MC L2 by I2 plus L3 by I3 plus MD L3 by I3 is equal to minus 6 A2 X2 bar by L2 I2 plus A3 X3 bar by L3 I3 plus settlement conditions. So 6E HB by L2 plus 6E HT by L2. This is the sequence of the equation what we have followed in the previous slide also. So what are the segments will be 0 here? What are the segments will be 0? We are considering the second part of the continuous field. So this MB has some values, definitely. So there is some values at MB because it is an intermediate support. So MC, there is also some values MC because it is also intermediate support. So what about MD? Because it is an end support and it is a simply supported case. So MD we can consider it is 0. So moment at the simply supported end conditions that is 0. So MD is equal to 0 you have considered. Now next equation is if you rewrite after putting MD is equal to 0. So MB into L2 is nothing but 6 by 2y, L2 is 2y plus 2MC 6 by 2y plus 3 by I. Why 3? 3 is the length of the span CD. So 3 by I is equal to minus 6 into 27 into 3. 270 is nothing but your area into 3 divided by L1 into I1 plus 6 into A2 into X2 bar divided by L2 I2. So this is the values we have applied in the formula plus 6 into E value is 15 into 10 to the power 6 into HB. HB is here we have written positive as well as 0.005 half. So what is the settlement condition is given in the question? The settlement condition is here is B and D. So here is C. So here is C is settling down. So I can draw the diagram like this, right? So just creating a slope. So if I draw a reference line here again, if I draw a reference line, I can write, see, the delta C is not mentioned in the equation. So this 5 mm, we are not going to use in the equation. So what we are going to use? Just draw a reference line here. So that means for this reference line, what is HA? HA will be 5 mm. And for this reference line, what will be HT? HD will be again 5 mm. And what will be the sign convention? It will be positive, right? Because we are considering the reference line here. So when you consider this, so what will be the HB? HB is 0.005. We have converted into meter. And sign convention is positive divided by 6. plus 6 into 15 into 10 to the power 6 into 0.005 divided by 3. 0.005 is nothing but your settlement at B. So if you multiply both the sides, now just you just simplify this equation because two, three more steps can be written after this. So as the equation is drawn, so we can multiply both the sides by I values. So multiply the I values here. So if you multiply it with I, so I will be cancelled out. 6 by 2 will be 3. So 3 MB plus 12 MC, if you solve this, you will get 12 MC equal to this solution is minus 405 plus this total solution is 135 plus 6 into 15 into 10 to the 6 into 0.005 into 5 into 10 to the power minus 3. Where it came? 5 into 10 to the power minus 3 is nothing but your positive settlement, the positive value at A after settlement at B. Okay? So this is nothing but 5 into 10 to the minus 3 divided by 6. Plus, the similar fashion will write 6 into 15 into 10 to the power 6 into 0.005 into 5 into 10 to the power minus 3. This is nothing but your HC. This is nothing but your HA. So HA and HC, these two values is required. So, sorry, HB and HD, that was in the previous case, and that's for the span ABC. So in this case, span BCD, so this value is HB and HD. HB and HD. So further simplify the equation. It is now 3MB plus 12MC is equal to minus 405 plus 135 plus 375 plus 3750. So if you solve this right hand side things, so the final equation is 3MB plus 12MC is equal to 585. That is your equation number 2. I hope this is clear, right? So we have applied this three moment equation for the first two spans, span AB and BC, and we have written the equation, that is equation 1. Then we have considered the span B and C and D, and we have considered both are both are in one continuous moving conditions, and we have rewritten the equation, that is equation 2. So now we have two equations. How to solve? We have two unknowns also because MB is a unknown and MC is a unknown. So we have two unknowns and two equations. Equation 1 and equation 2. We have two unknowns and two equations. How can we solve? You can directly use your calculator, or in this way you can solve, like multiplying equation 2 by 4. So we have identified a common location or common point. Like if you multiply the equation number 1 or 2 by 4, so we are getting this 12MB plus 48MC is equal to this 2340. That is the equation number 3. Now subtracting equation number 2, whatever equation number 2 from equation number 1, we get 12MP plus 3MC is equal to this. 12ME plus 48MC is equal to this. That is the equation number 3. Now look, if you subtract this, so this will be negative, this will be negative, and this will be also negative. So 12MB minus 12MB, this cancels out. So 3MC minus 48MC, so it will be minus 45MC, correct? So this will be minus 979.8 minus 2340. You are getting minus 3319.8. So from this you can calculate the value of MC, that is 73.77 kilometer meter. So now substituting MC value. If you substitute the MC value in equation 1, what you get? MB is equal to minus 100 kilometer meter. MA is 0 and MB is 0. MB also minus 100 kilometer meter, and LCM 73.77 centimeter. Now we have calculated all the end results. Now what is the time? The time is we have to draw the bending moment diagram. So what is the steps? First is free bending moment diagram. Second, end moment diagram. Third is final bending moment diagram. So let us draw the individual diagrams or bending moment diagram. This is the individual bending moment diagram first one A B. So the maximum bending moment is 40. This is the bending moment diagram or free bending moment diagram of span BC, and we got it 90 maximum bending moment. So in case of span CD, we got the maximum bending moment 30. The formulas we have already discussed in the previous slides. So how to draw now the bending moment diagram? We can draw the free moment diagram first. It will be free moment diagram. In fixed bending moment, how to draw? So MA we got zero values, MD we got zero values. So MB we got minus 100, MC we got 73.33. So I think this diagram can be drawn in this way. Both can be drawn in the upper side, which I'm drawing it here. So if this is the case, so this can be drawn like this and like this. Also, but we have to mention the movement directions, clockwise and anti-clockwise. Okay. So yeah. So how to club it? I think we have missed that. So if you club it, so this is the main diagram, and we can put it in a board and like this. And the common things we can highlight: negative, and this is positive. I hope this is understood. How to draw the bending moment diagrams. So the summary of the lecture is, so what modification we have done, the three moment theorem related to the bending moment and the three consecutive supports. These are also we have discussed in previous lectures. So but the difference is if the support settles or sinks, an additional term is introduced in the equation to account for the relative settlement between the supports, which directly affects the bending moment. So what is the effect of sinking support on the moments? The settlement of the intermediate support induces extra movement in the beam. Why? Because of the settlement in the intermediate support, it induces the extra movement in the beams without external load. So this settlement generally increases bending stresses and must be considered in design to avoid the structural distress or cracking. So that is why this is very, very important to consider the sinking support or settlement support conditions. I hope this is clear. If any questions, so here is the summary of the lecture. So you just go through the summary of the lecture, and if you have any questions, you can ask me. Otherwise, we'll see in the next class.